Hello, my dear students. I'm Shams Tanvir, lecturer of chemistry in English medium day shift from Rajaputra Model College, and I welcome you to this online class today. And our subject will be the second part of electrochemistry. That is, in the previous class, I have discussed about galvanic cell and its structure, and along with electromotive force and its definition and the representation of half cell. And today I will discuss the next other things, that is mathematical problems regarding non-nest equation, then the structures of dry cell and fuel cell, rechargeable cells, etc. So let's start. So first of all, we have to know that what is cell potential. That is a standard cell potential, E naught of cell. So E naught cell is just like as electromotive force, but under certain conditions it's measured, that is at 1 atmospheric pressure and 298 Kelvin temperature, that is 25 degrees Celsius, and the concentration will be 1 molar. At this condition, the cell potential will be regarded as standard cell potential. So the next part is standard hydrogen electrode. So this hydrogen electrode is used as reference electrode. A reference electrode is such type of electrode which has known potential, electrode potential, and it can be used as cathode or anode, etc. So it's used to determine the potential of other electrode connected in the circuit. So here the standard hydrogen electrode is used, and zinc is used as anode. So this is the oxidation half reaction. And the next reaction is reduction half reaction, that is it's the reaction of hydrogen, and overall cell reaction will be like this. So this is the structure, and you can see that anode it's in the left side, and cathode it's in the right side, and salt bridge is used. So this is the structure. And standard cell reduction potential, the reduction potential is the standard potential. So in copper, if we measure this, that is copper is used as a cathode here. So the reduction potential of copper is positive, and at the next page you can see that standard electron potentials of so many elements are given, and at the top you can see that standard electrode potential, that is this is the potential expressed as reduction potential. So fluorine has the highest reduction potential, and at the bottom, that is silver, the potential is expressed here as oxidation potential. And at this page you can see that the hydrogen has potential of 0. So lithium has the lowest reduction potential, that is minus 3.05 volt, and on this page the fluorine has highest reduction potential, such as plus 2.87 volt. So lithium has the highest oxidation potential, and fluorine has the highest reduction potential. So you can clearly see that lithium cannot be used as cathode, it should be used as anode, because the potential value of lithium, that is in reduction, it's negative. So if any reduction potential of a specific substance is negative, it cannot be used as cathode, it should be used as anode. On the other hand, if any oxidation potential of a substance is positive, it should be used as anode, and it cannot be used as cathode. So it's the vice versa of these electrode potentials. Okay, so this is the information that will help you measuring the electrode potentials in any mathematical problems of a specific element. So there is an important information regarding the voltaic cells. So some galvanic cells are given here. So common alkaline battery, it has a voltage of 1.5. Lead acid battery, that means it has total of 6 cells, that is 12 volt each. That means total electromotive force of lead storage cell is 12 volt. And the other informations are not relevant. So let's go to the next page, that is Nernst equation. So let's take a look at the Nernst equation, that is E of cell equals to E naught minus RT by NF equals to ln concentration of anode divided by concentration of cathode. That means it is expressed as ln Q, or you can write this in a different form, that is 0.0592. that is, it is the short form of all the constants present here. Here R is the molar gas constant, T is the temperature, that is expressed in 25 degrees Celsius always, and F is the amount of 1 farad. 1 farad means 96500 coulomb. So all the values are constant here except the n. N is the number of electrons exchanged in a cell. In a cell, that is in a complete cell reaction, how many electrons are exchanged, it is the value of n. So this is the Nernst equation, and here is a mathematical problem solved for you. So please take a look at the question, that is to find the standard potential of M3 plus or M electrode. The M is a random electrode. You can measure, you can assume any electrode. It's not mandatory. So here the cell representation is given. The left side, that is anode, consists of M element, and the right side, that is cathode, it consists of silver. So the concentrations are also given. Concentration of anode and concentration of cathode are given. So the EMF of this cell is found to be 0.42 volt. So calculate the standard potential of half reaction of M3 plus and this half reaction. So this is the solution. First of all, please take a look at the question again, and after that you have to, first of all, to answer this type of mathematical problems, you have to first of all write the complete cell reaction. That means total anode half cell and cathode half cell reactions should be written together to write a complete cell reaction. So by cell reaction you will get the value of n, otherwise you cannot get the value of n. So the cell reaction is mandatory for this type of mathematical problems. So here the E of cell is given, that means electromotive force is given, and you can see that the equation has been written, and we have taken the value of EMF from the question, and E naught cell appears to be here 0.484 volt, and E naught of cell is the total measurement of cathode potential and anode potential. So E naught of anode is currently present here. So this is the value of E naught. Okay, so E naught is the standard cell potential of the following reaction. Okay, so we have to determine the standard potential of the half reaction given in the question, that is M3 plus 3 electron that is turns into the such type of reaction. So here reaction is happening. So M electrode is used as cathode here. So for this, which will be the electrode potential, we have determined. It is the answer. This is the answer. So here the mathematical problem has been solved. So you can review the question again. Okay, so this is the type 1 mathematical problem, and this is the second problem. So here's a reaction given, that is silver and cadmium is used, and the questions are what electrode potential for silver and cadmium couples are, the standard potentials are given, and we have to determine first of all the standard potential, and for there is a second question, that is for the electrochemical cell in which reaction takes place, which electrode is negative electrode. So we have to determine the negative electrode and the reaction. So first of all, the first one problem is very much simple. We have to just determine the half reactions of this cell. So we have written the half reactions, silver and cadmium. Here silver is the cathode. We can determine, we can see from the question given, and cadmium is used as anode. You can also see that from the question. So we have determined the electrode potentials and at last, at the second part, we have to say that the negative electrode is always the electrode whose reduction potential has a smaller value, or the electrode where oxidation occurs, that is electrode when the reduction potential has negative value, that means oxidation will occur at that specific electrode. So cadmium is the negative electrode because the reduction potential of cadmium is negative here. So that's why cadmium is used as anode and oxidation will occur at the cadmium electrode. So cadmium is used as anode. This is the answer. So this type of mathematical problems you will face, and you have so many exercises in your books, and you have done so many exercises in your class. So this should help you to practice more and understand more. So next topic is battery. So battery is a galvanic cell, or it's a group of galvanic cell connected in series. So batteries, we always know the batteries are such type of cells that can be used again and again for a long time. So the battery we know that is used in torches or small type of electrical devices such as remote. So the batteries used are they are actually galvanic cells, and they are called dry cell. So this is the structure of dry cell. You can see that the structure of dry cell is given here. So here we have inner case that is made of zinc, and it acts as anode, and at the middle of the cell structure, that is, here's the cathode, graphite rod, and there is paste of manganese dioxide, ammonium chloride and carbon. This is the electrolyte. So we are seeing that anode and cathode, and we are seeing electrolyte. So anode is made of zinc, cathode is made of graphite rod, and paste of manganese dioxide, ammonium chloride and carbon is the dry cell, is the electrolyte of this dry cell. So let's look at the description. Anode is zinc container, cathode is carbon graphite rod surrounded by powdered manganese dioxide and carbon, and electrolyte is ammonium chloride and zinc chloride. So this is the reactions of anode half cell and cathode half cell. Anode, this will produce zinc ions, and it will release 2 electrons, and cathode, it will